Hello everybody and welcome back. We're looking now at question number 12 on the 2004 Fermat paper. The point R is the midpoint of the line segment PQ, and S is the midpoint of line segment QR. If P has coordinates 2, 1, and S has coordinates 14, 7, then the coordinates of Q are... okay. What to do here? Well, I think maybe the first thing to do, draw the picture, and I would label Q as having coordinates, maybe X, Y. So, I know it was a line that looked a little something like this. Put Q up here with X, Y. And R sort of in the middle here, and then S in the middle of those. And P down here, I believe it was 2 something, 2, 1. We've got R, and we've got S here, and S was, we were told, 14, 7. Okay. So, we sort of want an equation or a way to calculate X and Y. What shall we do? So, you might know, and if you don't, now I'm going to tell you about it, that there's a formula for the midpoint of a line in terms of the two endpoints. So we can actually get R having coordinates of X plus 2 over 2. You just take the average of the points, and then Y plus 1 over 2. Okay. Now S is the midpoint of RQ, so we could average again and get equations for the coordinates in S that we already know. Another thing you could do is, since S is sort of, if we imagine a half and then a half of a half is a quarter, S is 3/4 of the way from P to Q. So what you can actually do is you could generalize the formula a little bit as well. S actually has... it's 3/4 X plus 1/4 2. And this will actually allow you, if you want any sort of fraction. So if you want something that's t and 1 minus t along a line, you just sort of multiply the 1 coordinates by t and the 1 coordinates by 1 minus t. So that's one thing that you can do, actually. We don't have to do that, of course. You know, if you didn't think of that, or if you didn't know that you can sort of do 3/4 or really any fraction along the line by appropriately weighting the x coordinates and y coordinates, that's fine. We can still get S as the average of the R and Q. So R has R plus 2 over 2, and then Q has X, so we average those. And then Y plus 1 over 2 plus Y, all over 2 again. Okay, so these give us equations for 14 and 7. So 14 has got to be x plus 2 all over 2 plus x all over 2. Or I could rewrite that as 28 multiplying by 2 on both sides is the same as x plus 2 over 2 plus 2x over 2. Now I can multiply by 2 again. 56 is going to be x plus 2x, so 3x plus 2. And then I can subtract by 2. I'll get 54 is 3x, and now divide by 3, and we'll get x is equal to 1 and 1/6? No. That'd be 48. 3 times, oh, it should be 18, shouldn't it? Yeah, 3 times 8 is 24, and then plus another 30. Yeah, okay. So x is 18. Is this all we need? Is there only one that has 18? Yeah. So we don't actually need to work out the y coordinate as 9, because there's only one of these that has an x coordinate of 18, so the answer should be D. If we want to double check, we could go a step further and say, well, 7 has got to be, it was the average of the y coordinate and 1, and then the average of that with y. So 14 is going to be x or y plus 1 over 2, and then 2y over 2 multiplied by 2 again. 28 is 3y plus 1. Subtract 1, 27 is 3y. Y is equal to 9. Either way would do it. You could have solved for the y coordinate, the x coordinate. You could have even solved for both. And however you do it, you still get an answer of D. And that does it for question number 12. So I will see you guys for question number 13 in the next video.